paste that in, and there it is. This function adds a and b and returns a result. And I put a little message, parameter a is the first number, parameter b is the second number, and return some result. Now, here's an interesting concept. You'll notice that down here I'm using a and b. And up here I am also using a and b. Okay? A and b, in truth, because I made them happen here, I defined them here in the main, and the main is ultimately going to be calling these functions. A and b already exist, and I don't really need to use them here, but because I did use them here, Python is going to create temporary variables a and b to hold what I did and run the addition. I hope I didn't confuse you guys with this. I could say L and J, or how about J like so, and K, maybe that would be better, a little less confusing. All right, when I make the mistake and use the same variables, and I'm not sure that that's necessarily a mistake, okay, but when I declare or create two variables here and I use the same name for the variables up here, that is called variable shadowing, okay, because that means that here I reserved a spot in memory for a here, but I also reserved a spot in memory for the a that I had created when I went into this function, because anything that's inside here gets created temporarily for use within the function. So let's go ahead and correct this to make that J, and we'll go over here and make that K, and since I'm doing all of that, let's fix it here. J, K, J, and K, and we'll fix it here. J and K. Really glad I did this so that I can expose you guys to the notion of variable shadowing. We'll learn more about that later on down the road. And K. Alright, so good deal. We're now using variable names that do not match what is going on in main. Okay? But if we did create an A up here, literally what would happen is when we went into this here little function in a new location in memory, a new variable called A would be created. It would run its calculations, and then when it left this function, when it did the return, then the new variable A and the new variable B in memory would be released. They would go away, and the results of the calculation would be popped in here. So what exactly is going to happen? Let's come on down here and let's make use of it. We're going to do the atom first, right? So I'm going to go X is equal to, save myself some typing since I've done this already. Grab those 3 lines of code, come on over here, and put them in place. Alright, so I have X is equal to atom A and B. So whatever was in A is going to be put into the J variable. Whatever is in B gets put into the K variable, and then we do the math. And since we're doing atom, we come up here to atom, and it does it. So here then, what it does is that it returns the addition. And if I wanted to, I could say L is equal to J plus K, and I could say return L. But instead what I did was I just simply accomplished 2 goals at the same time. And I'll leave that the way that it is so that you can see what's going on. Alright? So L gets returned. So in a sense, literally what's happening is the computer program, or Python, takes this entire function name and replaces it with whatever L is. Okay? And since X is going to be equal to L, X will be populated with the value that it needs to have, and we're good to go. The same is true with the subtractem and the multiplium. Okay, so I can do the save, and if I want to, I can just do a quick run to make sure that I don't have any crashes. There's that, and I'll go 2 and 2, and I didn't get a crash. So that means that it built the program correctly, and it's a happy camper. Okay, well, it didn't really build the program because it ran the script correctly, because Python is a script. It is not a compiled program, which we'll learn about later on in the semester. Okay, now we're ready for the output. Well, since I went through all the trouble to create functions for the input, and I want an output whose job is to print out some kind of a message and then an integer, why not go ahead and create a function that will do that? This is going to give us another little example, okay? And that is, as you'll notice that here, I didn't return anything. I just told it to return. So this function prints out the message, and by the way, I have to fix my comments. I totally did not do that. So this is J, K, J, K, make sure my comments are right, parameter J, and parameter K, is what they are, and then down here, parameter prompt is a prompt string, and then I return an integer, and then down here I go parameter A is the integer, and then this is the message. So let's go over here. Parameter message is the message. So I'm going to go ahead and call that A. Actually, no, I'll call it I for integer. And I'll fix this up here and call that I for integer. Okay? Make sense? Hopefully it does. So now what we're going to do is make sure that I'm recording. Yes, I am. Good. Now what we're going to do is, gee, we can run this thing, right? So let's see how it does. Do save. Run the module. Enter the first number. I'll go 2. Actually, I'm going to go 5. And the second number, I'll go 3. Hit enter. And it didn't give me any output. Well, duh. Of course it's not going to give us any output, because guess who forgot to call the module that I went through all the trouble to create? So I have a module called printInt, right? So let's go ahead and let's get our prompts and all of that going. Pop that in there like so. And again, this is all in the main. PrintInt a plus b is that. PrintInt a minus b is equal to this. PrintInt a times b is that. And now let's give it a try. Let's see if it runs. Run the module. We'll say 5. Hit enter. We'll say 3. And it comes back and says a plus b is equal to 8. A minus b is equal to 2. And a times b is equal to 25. Awesome. So we're in really, really good shape. The whole critter works. And we've made use of functions, which are in fact in Python, they are the way in which we do modules. And with that, I hope it made all good sense to you guys, and I say happy coding.